Okay, so in this video, we're going to look at logarithm definition, okay? So you'll hear this saying for the rest of the unit. The best way to solve an exponential, so if you want to solve an exponential function, that means you were given an exponential function, the best thing to do is to rewrite it as a logarithm, okay? Again, the best way to do this as far as solving an exponential is to rewrite it as a logarithm. Now, vice versa, if I was given a logarithmic function, then the best way to solve a logarithmic function is to rewrite it, okay, there's that rewrite again, but this time into an exponential function, okay? So, for instance, I have two forms. I have an exponential y equals b to the power of x. And then I also have, I have an logarithmic function where it's x is equal to log base b of y. Okay, so let's talk about some things first. How do we read these equations? Here we go. I'm going to highlight them as I go. I'm going to read it as y is equal to b to the power of x. Okay, otherwise 25 is equal to 5 to the power of 2, or you could say 5 squared. But the way that I'm going to read a logarithmic function, okay, is going to be the following. X, or something, is equal to log base b of y. I'll read that again. X is equal to log base b of y. Notice that I did not say that it was log base b raised to the power of y. That's not how we read it, okay? Y is not a power of this b in a logarithmic form, okay? So the way that I want you to interpret that is kind of look at y and b are on the same level, and this x is like upstairs in the exponent, okay? Whereas over here with the logarithmic function, x, log, and y are all on the same level, and b is almost like a subscript. It's a base, okay? Almost think of, if you want this right here, this x is like the attic, if you will, and this base right here is like the basement. It's below, okay? So logarithms and exponentials, the way they're related to one another, it's almost like they're inverses of one another. So if I had like previous stuff that we've talked about, let's say x squared, the inverse is square root of x. If I had x cubed, the inverse is the cubed root of x. It's basically the piece that otherwise these would cancel each other out, okay? So when we've had equations that look like this, and I've asked you to solve for it, and you're like, oh, if I take the square root will cancel this squared piece, and all I'm left with is just x. And remember on this, it's plus or minus 9. But my point is that these two kind of cancel each other out so that the x is left. They're called inverses of one another. Well, the same with logs and exponentials. They are inverses of one another. Okay, that's why they're interchangeable when it comes to their rewrites as far as this is concerned. Okay, so there's a couple of restrictions that are important, and you will learn this as we go more and more throughout this unit. B cannot be 0. It has to be bigger than 0, okay? And it cannot be 1 either, okay? It has to be either a fraction between 0 and 1 or a number that is bigger than 1, okay? And of course, this y over here, it also cannot be 0. It has to be a positive number. It has to be bigger than 0, okay? And the same thing over here. Oops, let me just go ahead and keep going with the highlights. This y over here has to be bigger than 0, meaning this b here it cannot be 1, and it has to be bigger than 0. And again, you're going to learn throughout the unit why these restrictions right here work, or why they are required, the more and more we learn about exponential and logarithmic functions. Okay, so the way we would read these is 25 is equal to 5 to the power of 2. And then 2 is equal to log base 5 of 25. Okay, so log base 5 of 25. Now, let's see what must 10 be raised to in order to become 1,000. Okay, so this right here, believe it or not, this is just the number 3. Log base 10 of 1,000 is just the same as if I wrote the number 3, and that's it. And the reason why that works is because I know that this is equal to something. Okay, we could call it X, we could even call it question mark. Okay, so the way we are going to convert between exponential and logarithmic functions is this reverse heart method. You start at the base, and then you do like a sideways heart, and then you're going to go and say that you have this 10 raised to the power, here's the arrow, raised to the power of question mark is equal to, let's come over here, those are the arrows, that's the reverse heart method, like roadmap, if you will, is equal to this number here. This number here is called the argument. This is the base, and this is just the number that it's equivalent to. Because again, this correlates with our exponential of 10 raised to the power of question mark is equal to the 1,000 over here. Okay, so we'll go ahead and write this. This is called, again, the reverse heart method. Now, that's just something that teachers kind of came up with just to help students with this unit, but it's the base raised to this number is equal to the argument. See, it doesn't have as good of a ring as reverse heart method does. And since we all, quote unquote, love math, we figured that's perfect. All right, so let's keep going. So you have to ask yourself, what number would question mark be to make this statement true, where 10 raised to some power would equal 1,000? Well, that number is question mark is 3. Okay, so again, our original log base 10 of 1,000 is just camouflaged, if you will, or coded as just the number 3. And how can we do that? The way I just showed you, the reverse heart method, by hand, rewriting it as an exponential function. Okay, and let me go back just a little bit to that example. Well, let me give you another example, actually. Let's say that we had log base 3 of 8. Actually, log base 2 of 8. Well, what would that equal? Well, let's say that we don't know what it equals. So we're going to say x. But if I use the reverse heart method, I could say 2 to the power of x. That's the rewrite. Remember, it's all about the rewrite. If we're given logarithmic, we rewrite it to exponential. If we're given exponential, we rewrite it to logarithmic. So we were given a log problem. We rewrote it as an exponential problem by doing the reverse heart method. And we know that x would have to be 3 in order to make that happen. So if x has to be 3, which is here, that means all of this is just 3. Okay? So just like when we saw this right here, it's just 3. If I saw log base 2 of 8, this also is just 3 because of what we used with the reverse heart method. And we have a joke for you real quick. Just down here, we have people have 10 fingers and 10 toes. That's why it makes sense to use the log base 10. And right here we have naturally, this other logarithmic function. This is dealing with the base is 10. And you'll learn more throughout the unit. And here, the base is E. And we know E from previous lessons that it's that 1828, 1828, 459045, so on and so forth. It just keeps going on and on and on. Okay? And we'll learn more and more on that as we go. Let me do one more example of how you can change an exponential, this time to logarithmic, because we've done 2 logs to exponential. But now let's do 1 exponential to log. Let's say that we had 2 to the power of, let's say, 4, and we wrote as equal to x. Now, we know 2 to the 4 is 16. But let's say we wrote this, and we were given this exponential function. Well, logarithmic-wise, we're going to write the base right after log, which in this case, our base from the exponential form is 2. So we'll write a 2 down here. And then we're going to kind of do it the same way, right? So 2 to the power of something is equal to something here. So you can, the way I like to do it is start from this what if logarithmic form. And I know over here, this one's saying 2 to the power of 4 equals x. So 2 to the power of 4 is equal to x. Okay, so the equivalent of this exponential function right here, 2 to the power of 4 is equal to x. The way I could rewrite its equivalent equation in logarithmic form would be this: log base 2 of x is equal to 4. Okay, and yes, we can go ahead and check it out and get our answer. We know that this is going to be x is equal to 16 over here. And let's say that I were to put this logarithmic form in my calculator and tell it to solve for x. Well, I can do that by the following. Let me go ahead and clear this up, and I'll press this button, find the log, and I'll say the base is 2. And that's what we have over here, base 2. The argument is x, and it's equal to 4. Now, I wanted the calculator to solve this, okay? So I should have started with menu, 3 for algebra, 1 for solve, and then I can go up here and just press enter to copy it, and then put comma x. Tell the calculator to look for this variable. You need that comma, and then you get 16, okay? So that came from this form right here, where you know that the argument x was equal to 16, okay? So just brief summarization, it's all about the rewrite, and it's all about knowing that the best way to solve an exponential is to rewrite it to a logarithm. The best way to solve a log is to rewrite it to exponential, and we're using the reverse Hart method to do it by hand, because we will definitely do a lot of these without a calculator. All right.